Hey kids, it's Mrs. Compton, and today I wanted to give you a blast from the past. If you can see this behind me, you'll probably be wondering why it's on the board. So you probably remember in first grade and second grade, we did a lot of work with fact families. All right, I hope you remember that, and I hope you remember if you find out one thing, like 5 plus 10 is 15, you can also find out that it has a fact family. You can use the commutative property and do 10 plus 5 is the same as 15. And then you also can do 15 minus 10 is 5, and 15 minus 5 is 10. All right, so we have 4 different boom, 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 boom equations in the fact family. Now, the same thing is actually true for multiplication and division, if you can believe it. So if I give you a problem, so let's say I want to give you 5 times 3. So 5 times 3. What does that equal? 1, 2, 3, tell me. 15. Can you find the other 3 fact families that would go with it? All right, so this would be a good time to hit pause. Can you figure that out? What would it be? Okay, so maybe you realize that you could use the commutative property in multiplication too. So we can also say 3 groups of 5, or 3 times 5 equals 15. And then we don't put in addition or subtraction, we put in division for the fact family. So 15 divided into 5 groups would be 3 things per group. And then we could also say 15 divided into 3 groups would equal 5 things per group, right? So we have a fact family. Those numbers stick together. All right, it really helps us to know that when we're solving problems, because I have a confession to make. When I get a division problem, I almost never solve it with division. I almost always solve it with multiplication. Now, I know there's a lot of people out there who probably do solve it with division, and that's totally fine. But that's just how my brain prefers to work. So I think we should take a look at a story together and see if we can relate that multiplication and division. All right, get ready. I'll be right back with our story. All righty, here we go. We've got Pam, and Pam is going to the fair. And I bet you've probably done some carnival math in your life. So maybe you can relate to Pam here. Pam went to the fair. She went on the same ride 6 times and used the same number of tickets each time. Okay, so if you get to your favorite ride and you just keep on going on the ride, they don't change the number of tickets you have to pay, right? It's always the same number of tickets. So she used 18 tickets. How many tickets did she use each time she went on the ride? Okay, so let's list off what we know for sure, and I'm going to try to stop laughing. I can't help it. Sometimes it's just my silly funny bone gets me. Okay. Pam went to the fair. Okay, we already know that. She went on the same ride 6 times. Okay, so we know that for sure. And she used the same number of tickets each time. Okay, same number of tickets each time. Okay, we also know that she used 18 tickets. And we are trying to figure out how much or how many tickets she had to pay each time. So how many tickets did she use each time she went on the ride? Okay, so I would love, if you have a whiteboard and marker or a piece of paper and a pencil, I would love for you to grab that, because the best way to think about this, I think, is just to sketch it out together. So let's do it. All right, so we're going to draw a model. So here we go. The whole amount of tickets that she used is 18. So that's what we're going to put at either the top or the bottom of the model. Doesn't matter. So we can put 18 either at the top or the bottom, representing the whole, okay? That's all the tickets she spent. So 18 tickets spent. All right, now, we also know she went on the ride, boom, times, 6 times. So I'm gonna break this into 6 pieces. All right, but I'm kind of crazy about breaking my model into equal size pieces. So I'm gonna start with thirds, like this. And then I'm gonna break each of my thirds in half, and then I'll end up with 6 pieces. And I don't even have to count. Okay, so now I'm thinking we are doing literally 18 divided into 6 equal pieces. So we're thinking about 18 divided into 6 equal pieces equals what? But you know what? My brain is not really thinking about that. Even though that's exactly what it's showing, my brain is thinking the opposite. It's thinking in its fact family because I like multiplication better than division. Maybe not you. Maybe it's just me. I don't know. So I'm thinking 6, 1, 2, 3, 4, 5, 6. 6 times what? 6 times what makes 18? Doesn't matter which one we choose. We're going to find the answer. So if you do 18 divided by 6 or 6 times 18, wherever that rectangle is, that's the answer. Okay. So do you know what 6 times 8? 6 times what would make 18? Could it be 6 times 2? That would be 12. 6 times 4 is double that. So that's 24. So it must be 6 times 3. All right, so if I put a 3 in each one of these, does it really add up to 18? We should always double check. 3, 6, 9, 12, 15, 18. So each one of these represents one turn on the ride. One time on ride, right? So each time she had to spend 3 tickets. So 18 divided by 6 is 3. All right, you guys, I don't know about you. Whatever way your brain works, it's magical. Love your brain and give it a chance to really think through what is happening. Make sure you have that picture in your head. All right, see you next time, kids. Bye.